Hi all, welcome to another blog in the EKS Anywhere saga series. In this blog, we will look at some of the advanced concepts when it comes to node pools and autoscaling from a EKS Anywhere cluster standpoint. In the previous two blogs, you have seen that we have created workload clusters with a standalone workload cluster or a workload cluster with a dedicated management cluster topology. Both topologies still are relevant. The only difference is now, if you want to have a cluster that has the support for autoscaling and with node pools, you can do so through a new template that actually has attributes embedded into that. Now, before we actually go there, let me share my screen here. Yeah. So you can see that in the previous two blogs, we had, the basic template which we use to create the management cluster, the workload cluster, and things like that. This is the template, right? And in that, the cluster configuration block has a section called as worker node group configurations. Now you can see that this is a simplistic picture of how a basic worker pool can be configured, where you have the count as 2. That means 2 virtual machines, and it references the vSphere machine configuration for that particular node pool of the worker nodes actually, right? Plus there are etcd nodes and control plane nodes, right? Now, this is where we will start changing the attribute set, where we will further bifurcate this particular node group configuration into 3 separate or 3 distinctive configurations. Couple of them with autoscaling support, and all of them will have a label that will identify uniquely those virtual machines in the cluster actually. So to do so, let me share my GitHub repo, and like always, this repo is ever changing. So if you have not, or if you're trying to kind of view this blog and trying to experiment with this, make sure that you reclone this particular repo so that you can get the samples and things like that. So there is a subdirectory here which says cluster-samples. Okay, this is the basic cluster template that we just kind of showed on the screen, and this is the new template. Okay. And this is again a sample. You can edit, for your convenience and what your objectives are. But let's look at some of the important things here. This is the block that highlights how the worker nodes will be configured in the cluster. And in the basic one, you just had 2 virtual machines. In this one, you see we have created 3 groups of worker nodes. One is called as MD0 with a label group MD0, and it has an autoscaling reference with a min count of 2, max count of 5, which means the virtual machines that will be hosting the worker node capabilities can expand from 2 to 5, and you can go more in this case. There is another node pool of worker nodes which I have intentionally created, which is called as MD1. And this has a similar min 2, max 5. The third one is a static node group with a group label of MD2 and a count of 3. Now, intentionally, there will be scenarios in the Saga series where we will run data on Kubernetes, DOK, or let's say, databases or data services, which are not ideal candidates for autoscaling, let's say that, right? Or you could think of, stateful applications, which really are not good candidates of autoscaling. So you can now think of a strategy where you have 3 node pools with individual group labels, MD0, MD1, and MD2. And each are uniquely identified in terms of their, whether they are autoscaled or not. And depending upon, what type of virtual machines you employ, whether GPU, non-GPU, or different kind of size and configuration, you can then place your pods depending upon whether they are good candidates or not good candidates and the situation. Therefore, in each of these node pools, right? Interestingly, in this particular template, I have also made sure that the MD2, which is really not the auto scaling, it's the static node pool with count 3, is given a higher vCPU, 8 vCPUs, and 16 GB RAM. Again, we will be running some scenarios later on in the Saga series where you could be deploying Postgres or a MySQL, multiples of them, and or anything. I mean, Yugabyte or whatever, right? In that case, these stateful applications they could be resource hungry. So this particular node pool has been kept to a higher configuration as opposed to the auto scaled workgroups, which are capped at 4 vCPUs and 8 GB RAM. Again, these are this configuration will be for each of the virtual machines that will be representing the node in that node pool, right? And they will be auto scaled. Now, before we move on, how do you deploy this particular new template is there is a handy automation script that I always use to create the cluster. It's called as create EKS cluster, and this has an embedded reference to the cluster basic cluster template. But let's say we want to create this new template or a cluster with this new template. There is another script called as create EKS cluster with add-ons, and in this you can specify the cluster file name. So while we have one sample that that is provided in this GitHub repo, you could have multiple templates, each with different kind of t-shirt sizes, configuration changes, or whatever. You can use this particular script where you can actually provide the input file name, and then it will render the cluster accordingly. Okay. I will move on to my EKS Anywhere administrative machine. You can see this, and within that, I already have the cloned GitHub repo. So if I look at the cluster samples, you can see that both the templates are available, the basic template and the template with the node pools and auto scaling, right? Plus at the same time, I have copied the script, which is called as EKS cluster with add-ons, into the home directory. Okay, so what we need to do is run this particular script, provide the input as this particular template name, and then watch the cluster creation, right? Before doing so, let's also go to my vSphere environment. You can see that this is the folder where the EKS Anywhere cluster machines will be created. When I create the cluster, this will be the folder under which you will see the virtual machines popping out actually. Okay, right now this is empty. Now let's run this particular script. Create EKS cluster. I mean, I can give the basic one or with add-ons. Okay. Now there's another interesting point here is that the topology implementation, that is a standalone workload cluster or a workload cluster which is supported through a dedicated management cluster, that topology still holds good. So with this script also, you could create a standalone workload cluster, or you could create a management cluster, or you could create a workload cluster with a dedicated management support. So in this particular example, we will just go ahead and create a standalone workload cluster, okay, which means that the workload cluster name and the management cluster name is going to be the same. Okay, so let's name it, let's say C4 test 1, C4 test 1, and I will provide the static IP address for the API server in the cluster. Okay, now you can see that the script prompts you, it basically recurses over that particular directory of cluster sample and asks you which particular template do you want to select here. So cluster template file name. I can still go ahead and create through this script also a basic template based cluster. But in this case, we will take this template here. Okay. You can see that the workload cluster name is C4 test 1. IP address is this. I'm selecting this template, which has the 3 node pools, MD0, MD1, MD2. MD0 and MD1 are autoscaling groups. MD2 is a static node pool with count 3, but of a higher configuration in terms of vCPUs and memory. So let's go ahead again. I've not extended this template yet for 1.25 and things like that of Kubernetes version, but we will be changing that soon. So right now it supports 1.21, 1.22, 1.23. So I will select 1.23 as the Kubernetes version, and you can see that the process has already been invoked, and this script will run for approximately 15 to 20 minutes, where it will start to create a standalone workload cluster with embedded management cluster capabilities, right? I'll pause the recording and we'll come back. I don't want to go back into explaining what's happening behind the scenes. The process is very similar to what you have seen in the previous 2 blogs, where we have detailed the workings of the cluster creation process and things like that. None of that changes. The only changes when the cluster lands, it will have now 3 etcd nodes, 2 control plane nodes, and 7 virtual machines, which represent the worker nodes. So total of 5 plus 7, so 12 virtual machines. That's what the cluster will be all about, actually. Okay, so we'll take a pause here and come back when we are done with yeah. Okay, so now we can see that the cluster has been created successfully. Since this is a standalone workload cluster, it has taken about 15 to 20 minutes. I don't know how much, I didn't exactly clock the time, but if this was a workload cluster with a dedicated management cluster, it would have taken possibly 5 to 10 minutes, right? That's the only difference. But now that the cluster is created, let's go quickly to the vSphere environment. And we can see that, like I said, 12 virtual machines should have been created. And all of them are prefixed with the cluster name that we provided, C4 test 1. These are the 3 etcd nodes. The C4 test with not the label of MD whatever are the control plane. So there should be 2 control plane nodes. Yes. And then the worker nodes, which are MD0, MD1, and 3 MD2s, right? This is what we provided as the configuration in the worker node pools, right? Note that these are auto-scaled ones, MD0, MD1. These are the static node pools with 3 count, right? We said the minimum configuration or the minimum VMs should be 2, so there are 2, and 2 in MD1 too, right? They can be scaled to 5, like we've specified in the configuration, and you can change the configuration at will by upgrading the cluster and likewise. But now that we have the cluster in play, okay, let's hop over to the machine here. Clear. I'm gonna use the switch cluster script like I have described earlier to set the kubectl context. Okay, so the switch cluster script will automatically set my kubectl context so that now I can view through kubectl the nodes too. Note that we will not see the etcd nodes here because the etcd in this case is an external etcd. It does not run the kubelet, so those 3 virtual machines will not be seen. EKS Anywhere also supports a collapsed etcd, but not a recommended one for production use. So we see about 9 nodes here, the same ones that we saw on the vSphere environment. To control, you can see the roles are control plane master, and the 7 worker nodes, which are distinctively identified through MD0, MD1, MD2, right? We can clearly describe one of the nodes to ensure that the labels are applied, or the group labels are applied, so that when we create the topology-based deployments to place the pods in respective node pools, those group labels are the ones that will help us actually. Okay. Now let me describe the node named as C4 test 1 MD0. And we can see that there is a label that has been applied by EKS Anywhere on this particular node, right? And likewise, it will happen for the other ones. So I'll not go through the other ones here. Now, how do we test this, right? Let's test this particular. First, we will start by testing the node pool configurations by placing the pod in respective node pools. To do so, I have a very simple example. And I'll provide this in the blog itself, so that if you want to experiment, we can do so. It's a BusyBox image. Okay, you can see it's a BusyBox image, and the replicas are 2, and there is some amount of resource limits I have specified here. But most importantly, there is a node selector parameter that I've given, and that says group MD0. Okay, let's start with first MD2. I'll make this node selector as MD2 here, so that these pods, 2 replicas, go and reside on the MD2. Okay. So the deployment has been created, which means there should be 2 pods. The namespace is default. So I'm just going to say, you can say, see that, the pods have been activated. They are now in a running status. This is a fresh cluster. You can see the age of the pod is just 11 seconds, right? We just deployed it. Now let's describe one of these pods to see if it has actually chosen the right node pool. Okay. So you can see that we had employed the label group MD2, which means our intent to deploy these pods are on the nodes which bear this particular label. And we can see here, when I describe the pod BusyBox, the first pod is deployed on this node, which already has the MD2 label, right? So this is the MD2 one. Let's also see the second pod. Okay, so it's 529. It may come up on the same node or on a different node, but most importantly, it has to come up on a MD2 node. Okay, so we can see that this one also has landed upon an MD2 node. So at least we know for sure that the node pool configuration is working on the EKS Anywhere cluster node. Now you can target your pods. Let's quickly do one more check, and we will edit the live deployment. Let's say cube editor equals nano, and we will edit the live deployment so that we can move the pods to a different node pool and quickly verify things. Edit deployment BusyBox. Okay. And this is the actual deployment that is running in the cluster for the BusyBox pods. Okay. Where is my node selector? Yeah. So the node selector currently is MD2. Let's make it MD0 and save this. You can see that the deployment has been edited. Now, if I get the pods, you will see the new containers are being created. Okay, and the previous ones will get terminated. Let's just watch this. You can see that the new container has been created and it's in a running state. The previous one is being terminated, right? Let's see this. Okay, so what happened is basically we edited the deployment. Now these pods need to be recreated on a different node pool, and that's what's happening here. Let's describe the newly created pods. You can see now the new pods have been created. kubectl describe pod. Let's take this. Now we have changed our node selector for these pods as MD0. And we can see here, yeah, they have been now placed on MD0 node, right? And likewise, it will be the same for other one. We can quickly check it. Okay. Yeah. This is the second pod. And this has also come up on the new node pool, which is MD0. So that concludes a basic validation of how, and we can do this for MD1 as well, right? So that's not the point here. The point is that you can easily validate. We deployed a cluster configuration with support for node pools. We deployed BusyBox on MD2 node pool, the worker node pool. We then shifted it to MD0, and by virtue of just attaching the right labels and the identifiers, you can actually shift pods, right? So the point is that you could have deployments which can be categorized into different node pools depending upon the underlying capabilities of these virtual machines. This becomes important, like I said. Either you could have applications which are resource hungry going on one, or having a different set of characteristics going on another node pool and things like that. Now, once we've done this, it's also imperative to understand that we've also employed autoscaling, right? And just by configuring autoscaling on the cluster as such, it does not do anything. It will not automatically scale just because you have put min and max values for a node pool. You need an instrumentation that will actually activate the autoscaling, right? And there are various ways of doing that, but one of the most easiest way, let's say, is the cluster autoscaler. Now, cluster autoscaler is an open source project that actually watches for pods that actually get into a state of pending, right? Because of resources not being there on the virtual machine and things like that. And that's where cluster autoscaler will watch that, okay, there are n number of pods that are not able to be deployed, or they are not getting into that running condition because the resources are not available in the underlying EKS Anywhere cluster or any other cluster. Cluster autoscaler supports. Now, cluster autoscaler has support for different infrastructure as a service provider, AWS, Google, Azure, and whatnot, right? I mean, and upstream. And it also has support for cluster API. Okay. If you recall the architectural specs in the conversation we've had in the previous blog, EKS Anywhere on vSphere environments is completely deployed or instrumented through a cluster API implementation under the hood, right? That's what runs under the hood. So you need cluster autoscaler to be implemented onto this cluster, but with the specs of cluster API. And I'll show you basically how it is done here. And again, these configurations will be there for you to see. But before we do that, we will deploy quickly a metric server. Now, metric server will give us some bit of leverage on validating the node metrics and the container metrics and all that. I have a YAML that takes care of deploying the metrics server. So I'll first deploy a metrics server, not that it's needed for cluster autoscaler again, but I'll just kind of do this here. Okay, so now once the metrics server is employed or deployed, we can watch for some of the metrics related to the cluster here. We'll just let this deployment and the containers come up. At the same token, we will create the cluster autoscaler. Now, cluster autoscaler does not really depend on metrics server. It basically depends on the state of the pod. Let's say that, right? Let me just do this. Yeah. Like I said, the cluster autoscaler will watch out for pending pods which are not able to be delivered for lack of resources in the underlying cluster. Okay. Now, there's another important attribute or aspect we need to understand of the cluster autoscaler. Cluster autoscaler will only resize the cluster in terms of virtual machines, which means the overlay in terms of the pods, whether they are 2 pods or 20 pods or 200 pods, is done through a separate construct called as horizontal pod autoscaler. That is to actually expand and shrink the footprint of the deployment or the pods. And you can blend in both such that you can create a horizontal pod autoscaler, which depends on metrics autoscaler, metrics server to see the the containers or the pods utilization, and then automatically shrinks and expand the footprint on the pod level. Now, if the pod resources are kind of being challenged, it will introduce new pods. And when the new pods occur, they depend upon the underlying cluster's capability in terms of sufficing the deployment, right? And that's how you can automate the full. And we'll see those advanced examples in the next sections. But for now, what we will do is we will deploy the cluster autoscaler, but we will manually increase the number of replicas of BusyBox, such that when you increase the number of replicas for the BusyBox, there is a demand placed on the underlying cluster resources to have those number of replicas delivered. And that's where the challenges will come up, because you can only deliver so much with a certain capacity of the virtual machine. And that's where cluster autoscaler will kick in and increase the the footprint of the virtual machines for a particular. Now, this is important because now we deployed this pod on MD0. This won't happen on MD2, which is a non-autoscaled worker pool, right? For now, we will go ahead and deploy cluster autoscaler. In order to do so, there's an important, this one. You can see that the cluster name has to be specified appropriately. So I think we named our cluster as C4 test 1. So I have to change this to C4 test 1. Otherwise, the cluster reference is not established properly in terms of auto discovery. And the most important thing you can see here, the arguments provided to the cluster autoscaler, is that the cloud provider is cluster API. Okay. If you were to deploy a cluster API on AWS in the public cloud, it will be a different set of arguments that you will provide for. Okay. So let's hope this one goes through smoothly. This is a live demo. Anything can happen. Okay. Okay. So now we've actually deployed the cluster autoscaler here. And if I was to kubectl get pods -a, and let's see if the cluster autoscaler is also deployed for me. BusyBox is there. Zillion, cloud controller. It's just grep cluster. Okay, so you can see that the cluster autoscaler controller is running. Okay. And let's also see if the metrics server is running. Yeah, you can see that the metrics server is also running. And we know for sure that BusyBox also is running. 2 pods, and BusyBox is running on MD0, which is an auto-scaled group. Now, how do we really test auto-scaling? And again, we've not gone to an extent of fine-tuning the autoscaler configurations, which is the cooldown timers and the different timers involved in order to quickly react to the resource requirements. We can do a lot of fine-tuning in that aspect to suit individual kind of deployments here. For now, we will go with whatever is available in terms of the default. And how do we test it? So we've already tested the node placement of BusyBox onto MD0, MD2, and likewise. Let's just go ahead and edit kubectl cube editor equals nano kubectl edit deployment BusyBox. Okay, and what we're going to do is we're going to increase the number of replicas here to, let's say, I don't know, let's make it 50. Will that give me enough? Okay, I don't know, maybe it's more. But our upper cap for the auto scaling group is 5. So I'm not doing an exact math here. I'm just kind of making sure that there is enough load on the system. And let's see. Okay, so you can see that let me reduce the font a little so that we can verify things easily. Okay, so you can see that a lot of pods are now into running / pending, which means that the pending pods are creating a undue requirement because there is not enough resource in the node pool called as MD2 or MD0 in this case, which can deliver these pods because of CPU requirements, right? Now, if I say kubectl get nodes now, you can see that MD0 nodes, we had 2 nodes, yeah, and 3 more nodes have been initiated, the creation of 3 additional nodes, right? So our upper cap is 5 nodes, and you can see that to an extent possible, cluster autoscaler is now has seen the pods are in pending status. So it is now creating the additional nodes through the cluster API under the hood, talking to vSphere to provision these additional virtual machines, but only in the node pool called as MD0 because the BusyBox pods are really running on MD0 here, right? Again, I'm not going to go to a greater level of detail, but you can see now that all the 5 nodes are ready, right? MD0, whatever, right? The numbers, and we can verify this in the vSphere environment also. You can see that the count of MD0 nodes has been risen from 2 nodes to 5 nodes, which means that whatever these 5 nodes can kind of suffice in terms of the number of, we've given a pod count of 50 now, but whatever can be delivered through these 5 nodes, right? We can always kind of go ahead and increase or change the auto scaling configuration on the cluster by editing the cluster template. Say our min count is 2 and max count is 5. We can increase it to 50 and it also depends upon the underlying vSphere capabilities, right? In terms of, or the vSphere capacity, in terms of, how big your actual physical infrastructure is. Now, that's where this also relates to, a lot of as a service models and flexible consumption models that are available. Specifically, if you look at Dell's Apex portfolio, right? You can actually visualize that you can buy or kind of subscribe to these environments or stacks, which gives you a handle in terms of that you pay for a baseline capacity, and then you have a buffer capacity which is ready available, but you don't pay for it unless consumed, right? So you commit to a baseline. Now imagine I'm just trying to kind of build a correlation model here where you have a steady state cluster running, you have a peak requirement that comes over a weekend or a quarter end or a whatever, right? And then you expand your cluster, like what we've seen here through cluster autoscaler. And when that happens, the number of nodes or the virtual machines in the cluster will increase. And you can keep increasing to whatever, the underlying physical capacity is. But you will only pay for the baseline resources, as you would subscribe to the Dell's Apex model. And then when the cluster moves into that buffer state, let's say autoscaling kicks in, you expand, you pay for it only when that autoscaling is really kind of, activating those additional nodes. And as your peak requirements kind of shrink, the autoscaling will bring it back to the original cluster state, right? And we can see that as well. And that's where your entire consumption model, the business model around the economics, plus the technology model in terms of supported through cluster autoscaler and whatnot, everything kind of falls in place where you can align your technology design to a consumption model such that you can greatly benefit from your peak business demands and the way it's delivered in the on-prem model served by EKS Anywhere. So now, we can see a lot of it would be in running as opposed to previous 2 nodes, but some of it will still be in pending. Maybe there is not still, after the 5 count of the nodes, there is still not enough requirement. We can edit that, but it's going to take a longer time because once you edit the template of the cluster, you have to upgrade the cluster to actually, kind of have the new configuration. So that could take a time. Now, what we will do is we will edit the deployment and get it back to, let's say, the original count of 2. Okay, so that the additional pods get terminated. Okay, so you can see that the additional pods are being terminated. And when this happens, the pod count will go down. The resource requirement on the underlying cluster virtual machines or the cluster's node pool MD0 will also come down. That's where cluster autoscaler will also look out for these changes and shrink back the original, the node count from now the max count of 5 to a min count of 2 or whatever, is being required by the number of replicas that BusyBox will be accounted for. Now, this takes a bit of time. I think it will take about 10 minutes or so, depending upon the timer set in autoscaler and all that. So I'll just pause here. When the entire process is complete, we will observe the initial state of the cluster through cluster autoscaler, scaling the entire node pool of MD0 down back to 2. Okay, so let's just wait for it. So good. We can see after a while the 5 nodes for MD0 node pool have been successfully scaled back to 2 nodes. Yeah. And this is the result of the BusyBox pods kind of shrinking down back to 2 replicas instead of 50. The load expected on the nodes has also reduced. And that's where the cluster autoscaler has kicked in. Takes a while since we've not fine-tuned the configurations, but eventually it happens, right? And like I said, you know, this really has to be, since we were manually scaling the replica count, but you can employ a further level of abstraction through a HPA, horizontal pod autoscaler, which will increase and shrink the scale in, scale out the pod replica count. And then, the resulting load expectation and the cluster autoscaler, they work in tandem, right? But I hope at the end of this demo, you've been able to kind of visualize and realize how EKS Anywhere can work with topology-based architectures in terms of node pools and also autoscaling. So again, thanks for watching. I hope you get a sense of what we've been trying to achieve here. We will be using this cluster template in some of the advanced configurations when we come to those scenarios. So thank you. Have a nice day.